Okay. Let me know if that shuts off. Would you do that, Massa? Massa is my new videographer. That shut off. I'm just going to repeat this quickly. Okay. So we're trying to find out a 0.61 molar solution of sodium acetate. Okay. Sodium acetate. Okay. That's the solution. That came from a 5% solution, 5 grams per 100 milliliters or 100 cubic centimeters, correct? Here are the equations that bring us to this point. This is the this is the operational equation relative to the Kb that we're going to use, where we're putting acetate into water and you're forming the acetic acid and the hydroxide. Excuse me. And that's the products over the reactant. So we know that it's a 0.6 molar, so now we can start. What is the Kb? What is the Kb for acetic acid? I will give you the Ka for acetic acid. The Ka equals 1.8 times 10 to the negative fifth. What is the Kb? How would you do that?
For acetic acid.
For acetic acid, correct. Okay, you would do that by saying the Ka times the Kb equals 1 times 10 to the negative 14. Okay, so you're going to divide through. So what is 1 times 10 to the negative 14 divided by, you want to divide through by Ka, and that will be Kb. So what would 1 times 10 to the negative 14 divided by Ka equal? Anybody get it? Is anybody working? Massa, are you with me? You have a calculator? Did it go off? Okay. Jen, you with me, or yes, you're with me? Excellent.
Is it 5.56 times 10 to the negative 10?
That's correct. Did you get that by looking it up, or did you divide through?
I divided.
I want everybody to divide through and get it. Musaba, do you have a calculator? Excellent. You want to work it? Okay, good. Excellent. Dennis, you got the grade? You got the value? Did you do it? You're working on it. Excellent. 1 times 10 to the negative 14 divided by 1.8 times 10 to the negative fifth equals what?
5.56.
You got it? 5.56. So that's going to equal 5.56 times 10 to the negative 10. Correct? Is that correct? You get that? Okay. So what I want to do now is I'm going to erase this. This is my scrap paper over here. Okay. So now I have what the Kb is, correct? So the Kb is going to be 5.56 times 10 to the negative 10 equals the K expression. Excuse me.
I think I made a mistake. I divide by 1.8 times 10 to the negative third, 6 to the negative fifth.
So what's the answer?
I'm doing it right now.
Okay.
For acetic acid.
First thing, what did you get?
5.56 times 10 to the negative 10.
Oh, okay.
Do you want me to check online?
Go ahead. We have a question as to whether or not that's correct. Shall I do it as well?
Yeah, online it also says it's 5.56 times 10 to the negative 10.
Did you get it?
Yep.
Everything's okay? May I continue?
Yes.
Why are you apologizing? We're verifying you had reasonable reasons. Okay, you had reasonable evidence, reasonable allegations. That that was wrong. Excellent. Okay, so what do we got? So when this is 5.5 times 10 to the negative 10th, is that going to be a strong base? Is the acetate ion going to be a strong base? Yes or no? Remember, it's attracting a proton, isn't it? Correct? So is it going to be a strong base? No, it's not. How do you know it's going to be a strong base or not? How do you know? Has anybody done any reading? I saw you doing a lot of problems there, but the question is, have you learned anything? If you do all the problems and you learn nothing, then was it a reasonable exercise doing the homework, doing the problems? No, it was not, Musaba. Well done. The wisdom of the desert. I love it. Excellent. Well done. So, how do you know from your voracious reading that the acetate ion, based on what's on the board, is actually a weak base? What evidence do you have? Anybody? That's a very small number. That's a very small number. For that to be that small, what does that mean? That the denominator would be very what? Very large, and the numerators would be very what? Very small. So therefore, is there a large dissociation happening with the water to produce hydroxide, yes or no? No, absolutely not. This indicates that there's a very small dissociation. Do you get that? For that to be so small, that acetate has to be large. And these products have to be small. Therefore, when that equals HAC plus OH, sorry, HAC times OH. And that's going to be AC, right? Yes? So it's going to be very small. Now, what is the concentration of the acetate ion? The starting concentration of the acetate ion. What is it? What's the molarity? This is Sunday morning, and you would think that no one's here. What is the concentration of the acetate ion? I put it on the board. It's what?
5%.
It's 5%, but in terms of molarity, what is it? It's on the board. 0.61. So this becomes 0.61. Yes? This becomes 0.61. 0.61 molar. Now, when this dissociates, when that grabs a hydrogen to form acetic acid, and you're left with a hydroxide. For every hydroxide, how many acetate, for every hydroxide, how many acetic acid molecules will be produced? For every hydroxide, how many acetic acid molecules will be produced? How many? Anybody? Nobody? Muhammad? No? For every one of these you produce, how many of these will you produce? Jen? For every one of these you produce, how many of these will you produce? One. So it's 1 to 1. So does that molarity, is that going to equal that molarity, yes or no? They're the same, aren't they? And we're looking for OH. We're going to call OH X. Can we call acetic acid, can we call that X? Can we? Can we call that X? Yes or no? Yes, of course we can call it X, because that equals that. They're the same, aren't they? Because for every acetic acid that I produce, for every, what's left over? One hydroxide, so it's 1 to 1. So I can call, if I call that X, I can call the other one X. So what can I call it? I can call it what? X squared. Correct? Yes or no? Let me ask you one more question. isn't that value that's in the equation going to be minus x? Isn't it? The final equilibrium that goes back and forth, the final equilibrium, isn't that going to be 0.61 minus what dissociated, yes or no? Yes, but is it going to be so small you can ignore it? The amount of the acetate ion that's actually lost in the dissociation is going to be so small that you can ignore it, because this is 0.61, that's hundredths place. What is the place value of the dissociation constant? Millionths is -6, billionths is billionths is -9, 10 billionths is -10. So it's going to be 10 billionths place. So can you ignore that value? You absolutely can. So this is the problem. I want you to find x. Do it right now and we'll come back. Clear? And we'll do part 5. Yes? So find the value for x. This times this, then square root. We'll be right back.